Okay, before I begin, I have to start with the traditional, please subscribe to my channel and please click the ring button so you'll get an alert when I do a new video. All right, I just wanted to give you guys an update on progress on my 1510 meter kind of BitX dual bander. A lot of stuff has been added to the board that you can see here, and I'll just describe it briefly. I'll go through each one. First, I want to point out that I have kind of filled up the back porch. This is the back porch area here, back here. I had to put on a little board underneath, a piece of plywood, because I discovered that I was not having enough room on the board that I started out with. So I built this back porch, and I'm quite pleased with it because it's allowed me to put up on the porch just about everything, I think everything that I needed to get on there. So now I'll talk about this in a minute, but I'll show you what I have on the back porch. First, I built this little bracket for the BNC connector for the antenna. And I just made it out of a little piece of aluminum box that I had picked up at a Hamfest. I thought about buying one of these little brackets on the internet, but they wanted like $7 for it. And the shipping was unbelievably expensive, more expensive than the part. And so I just decided, no, man, this is a radical fundamentalist homebrew project, so I will make my own bracket. And I made a second one for DCN. So those are two brackets that I have on there, and they worked out quite nicely. It's quite a satisfying little build. Then I put the filters on the back porch. This is a low-pass filter. I start out with a low-pass filter, comes in, and both on receive and transmit, the signal will go through the low-pass filter. I have the cutoff at about 29 megahertz. So this means that it'll allow the 10 meter signal to pass, but it will also knock down the second harmonic of the 21 megahertz signal, which will be at 42, and everything above will be knocked down. So this low-pass filter should work quite nicely. Mike, WN2A, sent me a whole bunch of -6 toroids. So I have an abundance of -6 toroids, and I glued 2 of them together here to give a little bit of additional power handling capability on the toroids. And I used my nano VNA to test it out to make sure that it was doing what it's supposed to. Anyway, I promised to pivot here and zoom in. Look at this, watch this, look at that. Okay, so I'm pivoting and I'm zooming now, look at that. There is the low pass filter, all right? Nothing real fancy. You could also see the 2 little bits of stock that I've turned into brackets, all right? Then I built a 15 meter bandpass filter. And this was based on a design by Martin, Papa Alpha 1, and I forget the rest of his call, but I have it up on the blog. And it is really just 4 series LC circuits with caps to ground, and it provides about 15 dB on, it's flat along the portion of the band, of the 15 meter band that I need to be flat, and the skirts are quite steep. So it provides, I think, at about 60 dB of attenuation for the other signal that's coming out of the mixer. So you have basically coming out of the mixer, you have signals at 28 megahertz, and you have signals at around 21 megahertz. For this filter, I want the 21 megahertz signals to be passed, but I want the 28 megahertz signals to be knocked down. And this knocks it down by about 60 dB, which should be fine. The other thing that I have on the back porch is I went ahead and built in similar fashion, there we go, we'll zoom in, the 10 meter filter that does exactly the same thing. But I discovered something, and this is something that Farhan had mentioned to me, and I didn't quite understand it at first, but when I built these things, I understood it a little bit better. And let me just show you this picture here, but I'll just tell you what it is. When you're building filters like this, one side of the filter, the shape of the filter passband, will have a steeper skirt than the other side. So when I'm on the 15 meter filter, I have a steep skirt on the high portion above the center line, And that really helps knock down the higher frequencies at 10 megahertz. I'm sorry, at 10 meters at 28 megahertz. So that was great. But when I went over here and built the same thing for 10 meters, again, I had the high portion, the steep skirt above the center frequency, when I really could have used the steep skirt below the center frequency. However, there's a way around this. Let me just first, I'll illustrate what I'm talking about here. Look, let me just draw, I'll put this here. Hopefully you guys can see it. Let me put it here. I'll zoom out a bit. Look at this, I'm zooming. Oh, there we go, look. I'm zooming, okay. All right, so you can see what I'm talking about in terms of steep slopes. This one, which is the one that I have here, has a steep slope above the center line. And that's really good, because if the center line is 21 megahertz, then 28 megahertz is way down here, maybe 60 dB down. And I wouldn't be getting so much attenuation if I had been on the other slope. So I need something, I need kind of the mirror image of this. However, if I built this bandpass filter on 10 meters the same way I built it on 15, I'd end up with a similar arrangement of steep skirts. The steep skirt would be on the high side, but instead I really need it on the low side. However, there's a way around this, and that is to put the resonant frequency elements, let me zoom here, go up here, put the resonant frequency elements here, make them parallel, 4 parallel resonant circuits connected along the top by the capacitors. So that would actually result in a skirt like this, and it would allow better attenuation. Right now, the way I have it built, it's going to attenuate the 21 megahertz signal by about 40 dB, which is good. It's not as good as 60 dB. So what I'm going to do is rebuild the 10 megahertz filter, and rebuild the 28 megahertz filter, or the 10 meter filter, and build it so that I have this kind of slope relationship that we have here. And that way I should get similar attenuation to the unwanted signal output of the mixer on 10 meters, similar to what I get on 15 meters. Anyway, that's kind of an interesting aside. Also, I have on the porch, and I'll go back out here, let me expand, let me zoom out a bit. I have put in relays, 1, 2, 3 relays on the porch. And this is because I'm working on what I call a relay plan. All right, let me put this here so you guys can see what I'm talking about. So I find, even though it's a simple dual bander, I find that it can be kind of hard to follow where the relays are, how the relays are working. So I just sat down and was noodling, and I came up with this little relay plan. And this is what I've built so far. So we start out, we have the antenna goes to the low pass filter. I talked about that before. And then it goes to the PA output, to the first TR relay. And when it's in receive, and it's usually received when the relay is not powered, it just goes over here, and then it goes into the bandpass relays, and the bandpass relays are selected to go either to 15 meters or to 10 meters. Now I have built, actually, you can see it here, this little switch. On one side it says 10, on the other side it says 15. And when I activate this, it activates this relay, these 2 relays, and selects the bandpass filter for 15 and 10. It also changes the frequency, shifts the frequency of the VFO a little bit, and that allows me to go from 15 to 10. It works quite well. Dean was making fun of me because I was doing this by just putting a whole bunch of test leads in there and clipping and firing the relays. And I got civilized and put the switch in there. The switch will eventually go on the front panel. All right. So this is what I built so far, and I mark with yellow the leads that I put in so far. All these relays are on the board, and I just put these in here. So what remains to be built is I have to build the power amplifier. I also have to build a mic amplifier, but these are tasks that'll take place during the weeks ahead. Anyway, that's the relay plan. Now let me put the board back over here. I'm going to zoom out a little bit here. Hold on. Zooming out. There we go. All right, go up like this here. All right, so we, oh, over here, look. This is an interesting development. So I started out by showing you guys a video of the of how great this receiver was, but before I built the audio frequency amplifier. And I had a little LM386 board going to a guitar amp. And oh man, it sounded nice. And people were sending me all kinds of messages saying how wonderful the receiver sounded. It sounded great. But of course, I knew I couldn't do that, and I needed to have a Homebrew board in there. But I've gotten kind of bored and lazy, and I don't like building audio amplifiers for some reason. But I realized that I have a number of audio amplifiers here around me in the shack that we built for the high school direct conversion receiver project. And it's just real simple. It's just 3 little common emitter stages that provide audio amplification. So I took one of these out of one of the direct conversion receivers, popped it in here, and I was listening to it, and it sounded not as good as the guitar amp. Not as good as the guitar amp of the LM386. So actually it was good that I had started out with the guitar amp in the LM386 because it provided a basis for comparison. The question I'm asking is, how come this Homebrew audio amplifier, when it's plugged into the same receiver, nothing else has changed, doesn't sound as good? The receiver just doesn't sound very good. So I kind of scrutinized it a little bit. I took out a audio waveform generator, and I kind of swept the audio frequencies. I put the audio frequency generator in here at the input, put the scope here at the output, and just watched what was happening as I moved the audio frequencies from 0 up to about 3 or 4 kcs. And what I discovered was that this audio amplifier was dropping off the lows pretty significantly. There were no lows in there. And then I started looking at the schematic, wondering what was going on here? Why was this amplifier being so sort of frequency sensitive? It should be passing all the audio frequencies, right? But instead, there was a cutoff occurring, I don't know, down around 600 or 700 hertz, and none of the lows were getting through. So it just wasn't sounding very good. It sounded bad. At first, I thought it might have had to do with the coupling capacitors between the stages, and I replaced all of those, and I boosted them all up to about 100 microfarads, but that didn't have any real noticeable effect. Then I looked at the capacitors that I had across the emitter resistors in all 3 stages, and none of these were larger than 47 microfarads. Now, 47 microfarads is probably fine. It's probably a very low reactance path for 1 kc audio. But when you start getting audio down to 400, 300, 500 hertz down in that area, it becomes a significant impedance. So I noticed that in the Hearing Aid 5 audio amplifier, on which much of this is based, in the final stage of audio amplification, they have not 47 microfarads across the emitter resistor, but they have 470 microfarads across the emitter resistor. So I figured, well, let me give that a try. So I replaced all 3 of the 47 microfarad capacitors. I replaced them with these kind of big looking 470 microfarad 16 volt capacitors. I had another one and I put it in there just to put some additional decoupling on the RF rail. And I looked at it in the scope, and it was very satisfying because now when I did the same kind of frequency scan across the audio frequencies, I could see the low frequencies were getting through. And when I hooked it up and connected it to the rest of the receiver, it was quite satisfying because it definitely improved the sound of the receiver. Now the receiver sounded as good as the LM386 and the guitar amp. So I think that was a very satisfying little fix. And I learned something there. You have to pay attention to the values of these kind of emitter resistor bypass capacitors. And I had not, and I think this is something that when I write it up, I'll put a note about this for any future builders of the high school receiver project. All right, let me go out here now, go back over here. You know, I thought about getting rid of this, the top portion of this inductor on the VFO. Looks kind of like a smokestack, but I think I'm going to keep it. You know, Todd out there in Portland said that he liked the looks of it. I kind of like the looks of it too, because it looks vaguely like a smokestack, makes the whole thing look kind of industrial. So yeah, that's about it. Everything's working fine, and I'm hearing all kinds of signals on 15 and 10. Hearing a lot of DX on 15 and 10. I hear such DX. I heard Indonesia coming through yesterday morning, and I was so fired up. I wished I could work them, but I couldn't because obviously I haven't built most of the transmitter circuitry yet. The transmitter amplifier will go here, and the microphone amplifier will go down here. And at that point, it should be pretty much in transceiver mode. But in the meantime, I'm just listening. So the Yankee Hotel 1 Alpha Alpha was just booming in here yesterday on 15 sideband. And I really wanted to talk to him. So I actually fired up my Drake 2B and Helicrafters HT37, sent it up to the hex beam, but I just could not get through. But it just was a sign of desperation there that I wanted to give it a try. But anyway, we're moving right along here, and everything's going okay. I do think it's worthwhile to noodle a bit, to look at this kind of thing, noodle. Think about what's happening with the bandpass filters like that, and just sort of noodle and experiment away. I think I'm going to use an RD6 amplifier here, and hopefully get, I don't know, maybe 5 watts out, or 4 or 5 watts out, enough to drive a little outboard amplifier. And I've been having a lot of fun with this project. I use this little Belden cable, this little coax cable, for a lot of the interconnects. And I don't know if you can see it, but let me zoom in here. But I kind of came up with a way. You come up with little innovations here as you go along. But take a look at one of these relays that I just put in here this morning. I'll zoom. Let me go up here a little bit so I can zoom. You can see it. You can see how I wrapped a little bit of solder wick, desoldering wick, around the outside of the relay. And this just provides a way to connect the Belden cable to the terminals on top of the relay, because the relays are glued down kind of dead bug style. So I just take the center conductor and put it on the appropriate terminal there. But then you need a place to ground it. So I just ground it to the little bit of desoldering wick that I've wrapped around the thing. It makes things a little bit neater. You'll notice that before I was doing this, the relays on the bandpass filter relays are a bit of a mess, and this just kind of neatens it up a little bit. So I kind of like the way I'm doing it there. I know there's a lot of people who'll say, why are you using relays? Why don't you use pin diodes? It's just that it's simpler, I think. Anyway, I've been just doing it this way. If they go bad, I'll just replace the diodes. It'll give me something to do. Oh, also, I did install, look at that. You see there underneath all those wires? That, my friends, is a fuse with a little diode to ground there. Reverse polarity protection. I think it's a sign of it's a sign of commitment to a rig when you actually take the time to install the reverse polarity protection circuits in there, because you're worried about blowing the thing up. So now the rig is protected from accidental reverse polarity. Let's see, what else did I want to talk about? Now, the whole relay thing, the whole bandpass filter thing was interesting. And I think we'll have this thing done in a little while. I'll build the amplifier and the mic amp. The relay systems are basically in. I'll have TR. I'm going to put a front panel on it. put a speaker behind the front panel, box it up a little bit, and then hopefully Bob will be my uncle and I will be on 10 and 15 meters as the sunspot cycle heats up. Anyway, that's it for now. Anybody has any comments or questions, please let me know. You can put it in the comments. Again, subscribe to the channel and click on the little bell. Thanks a lot. 7-3 from Northern Virginia.